Alright guys, so moving now to example 9.20 on page 365. Actually it is 364 and 365. It's going to be on 2 pages. And again, I just taught you, gave you the strategy on how to solve all of these empirical formula problems. And so we're going to use now this strategy to solve this problem. Okay, so let's start with what's given. So analysis of a sample of ibuprofen, the active ingredient of Advil, shows that the sample contains, and I'm going to right away get the what's given. I'm going to state it right away. 7.568 grams of carbon. My next mass is given hydrogen, 0.881 grams of hydrogen. And what else contains in that active ingredient of Advil? 1.551 grams of oxygen. Okay, now remember the previous example. The previous example contained percentages. We had to assume we had 100 grams so that we can right away convert to from percentages to grams. Here they gave us straight in grams, so we don't have to invent anything in here or convert anything in here. We just have to skip the step with the assumption that we have 100 grams because everything already given in grams, in the unit of grams. And so all we're looking right now for pretty much is S, H, O, and we're looking for the moles now for each element in this compound. All right. Again, the first step, we're going to convert from grams to moles, and I'm going to use the periodic table to get my molar masses of each element. 1 mole, I like to use 1.008. I know your textbook talks about, states that it's a 1.01, so you can choose either. It doesn't matter. So 1 mole of oxygen will be 16.00 grams of oxygen. And so we can start converting it. Same units will cancel everywhere in here. And so we will have the desired units of moles. All right, let's do the calculations here now. So I got 7.568, divided by 12.01. So I got my first answer here, 0.6301. And again, I'm using the figure that is not significant. That's why I use as a lowercase, so that I don't have any discrepancies when the final answer is an intermediate result, and I don't have to have discrepancies in my uncertain number as I do the final calculation here. So now 0.881 divided by 1.008 will give me this one. It has 3 significant figures, so it will be 8.74. And I'm going to have a little 0 here. And again, I forgot to put moles of carbon, moles of oxygen. Okay, almost there. So now this one here is 1.551, and then it's divided by 16. And so what I got here is for significant is 0.0969. And I'm going to add 1 more digit, which is significant, 3, and okay, 1, 2, 3, 4, 1, 2, 3, 4, and then so the 7 now. Remember the even odd rule. So 5 followed by nothing, or if there's a 0 right now, I have to have 5, and I have to drop the 5. So I will increment this odd number become even number. So there will be a little 8 here. Moles of oxygen, by the way. Supposed to be moles of hydrogen here. My mistake. Okay, so all right, so I got my moles here. So I'm gonna now go get here, find my moles. Carbon is 0.6301 little 4, 0.874 little 0 here, 0.09 693 little 8. Okay, so the problem here is that it cannot be empirical formula because it has to have whole numbers. smallest whole number ratios. So remember this step, guys, that I performed at this particular, junction here with the last problem, is that I was looking for the smallest number of moles, and that's what I divided each and every now moles of each element by that number. So in this case, oxygen has the smallest number of moles, so I'm going to choose this number, 9, 3, little 8. I'm going to do the same thing, 0.9693, little 8, and that will be 0.0969, oops, it's supposed to be 9, 9, 3, little 8. All right, so let's do the calculations now. So 0.63014 divided by 0.096938 gives me C will be 6.5. Now hydrogen will be 0.874 little 0 divided by 0.09693 little 8. So the hydrogen came out to be now 9.01, which is 9, and the oxygen, of course, came out to be as a 1. Now remember how last time I talked about what after this step you get the number that is not whole number. What do you do in this case? Well, you cannot just round off this 6.5 to 7, because that would be too much of an error from the from the experiment. Now what you need to do is you need to remember I said use the 2, the 3, and the increment by ones until you do distributive property until you get the whole number ratios, small whole number ratios. Now the first digit I'm going to try is a 2 first. I'm going to say 2 times 6.5 looks like will be and again, I like to ask this question, how much? This actually looks like 13, right? So C13, 2 times 9, H18, and a 2 times 1, O2. So now this will be our empirical formula, okay? So this is our empirical formula, and that's the final answer, guys.